So what we have here is the basic stoichiometry of our project, trying to figure out how many milliliters were produced, milliliters of carbon, that is, carbon dioxide. What we started off with was 0.82 grams of the baking soda, which is our starting point to figure this out. We had, like the basic stoichiometry, you're going to put 1 mole of the product that you're starting off with, and at the bottom put the molar mass. From then you put 1 mole of each of what you're trying to find, and then at the bottom of what you start with. And then you also use the number of the balanced equation that was given to us during class, and from then on you just do the basic stoichiometry, and what you're going to find is the answer is 27 milliliters of carbon dioxide.
I'm going to talk about how an LED works. So what happens is electrons move through semiconductor medium and fall into other energy levels during their transit of the p-n junction. When these electrons make a transition to a lower energy level, they give off a photon of light. And when that light happens, then there you have it.
Batteries have three parts: an anode, which is negatively charged, a cathode, which is positively charged, and the electrolyte. The cathode and anode are hooked up to an electrical circuit. The chemical reactions in the battery causes a buildup of electrons at the anode. This results in an electrical difference between the anode and the cathode. You can think of this difference as an unstable buildup of electrons. The electrons want to rearrange themselves to get rid of this difference, but they do this in a certain way. Electrons repel each other and try to go to a place with fewer electrons. In a battery, the only place to go is to the cathode, but the electrolyte keeps the electrons from going straight from the anode to the cathode within the battery. When the circuit is closed, a wire connects the cathode and the anode. The electrons will be able to get to the cathode. However, these electrochemical processes change the chemicals in an anode and cathode to make them stop supplying electrons, so there is a limited amount of power available in a battery.